Alright, hello math fans. This is Mrs. Utegg with a video on the Polynomial Remainder Theorem. Before we start this video, this would be a great time to grab a healthy snack. Your chewing won't bother me, so you can pause the video right now and get a snack. Alright, welcome back. So as I said, this video is on the Polynomial Remainder Theorem. It can be used to find the remainder of a polynomial division problem quickly. And it says that the remainder of f of x over x minus a is equal to f of a. So pretty much this f of x here, this could be any polynomial. It could be, for example, x squared minus 4x plus 8. And then we're going to be taking that over x minus a. This is similar to synthetic division, which I'm sure all of you love. Synthetic division, this leading coefficient of the x minus a here has to be a 1, and well, to say it could be any constant. And basically what the theorem says is that if you take f of a, where this is f of x, you will get the remainder. So here's an example, I guess. Let's say that we have find the remainder when 3x squared minus 14x minus 29 is divided by x minus 6. Okay, most of you would do that through synthetic division, and that would work fine. You would get the remainder of negative 5, but if you wanted to do that even quicker, you could use the polynomial remainder theorem. And how that would work is, this is your function here, f of x, and you're going to put x, which is this a right here, which is 6. You're going to treat this as a function, and you're just going to put 6 where x is, pretty much, and that'll just give you the remainder. So it's, we put our 6's in here, we sub them in, and if we find what this is, if we evaluate this, are we going to get negative 5? Drum roll. We do. We get negative 5. So let's see another example here. It says determine if x plus 4 is a factor of 3x to the 4th plus 12x cubed plus 4x squared minus 76x minus 368. So of course we know, and that's not a typo, if and only if the remainder of that over 4 is 0, then it is a factor. This is not a new concept to you. I just want to say that again. So if we use the polynomial remainder theorem again, remember, just like synthetic division, this is going to be a negative 4 here because it's minus negative 4. So if we sub in, this is the function once again. If we sub in the negative 4 here, wherever we see x, we should get, if it's 0, we'll see it's a factor. If it's not 0, it's not a factor, because if and only if. So that's like 768 minus, oh, I have it right here. So yeah, if we evaluate this, we get 768 minus 768, so that's 0. Plus 64 plus 304 minus 368. That's just arithmetic. That's just a calculation, and we get 0, which means that yes, it is a factor. Yes, x plus 4 is a factor of this. I got one more for you tonight. It says using the polynomial remainder theorem. So I've stated that this is the way that you have to solve this to get full credit. Determine, if this were on a test, you would have to use the polynomial remainder theorem to get full credit. It says determine the value of b for which x plus 7 is a factor of 3x to the 4th plus 28x cubed plus 49x squared minus bx minus 7. So of course we're gonna, well, I'm not gonna give you any hints. Just remember remainder 0 if it's a factor. You can look through this video again. That's the great thing about these videos. You can rewind and watch it again if there's a concept you don't understand. So why don't you come up with the answer to this using the polynomial remainder theorem, and we'll compare in class tomorrow. Also, if you would like a proof of this, why the polynomial remainder theorem works, if you're wondering, since you're the honors class, don't tell the Regents class this, but since you're the honors class, I could do a proof during class, if you would like. So yeah, this is your only homework, to take notes on this and try example number 3. And bye.